Hello everyone. Hello everyone. In this video, we will discuss about readers and writers problem. This is also one of the classical synchronization problem. So next to dining philosopher, so we have another problem, and this problem also be related with operating system kind, like how we are accessing the common database. Suppose if at the same time if more than one process trying to access the common data, so how it is possible? So accessing, which means nothing but either he can read or he can perform the write operation. So while performing these two operations concurrently, so how is it possible to perform these two operations on the specific data? Okay, say for example, if you want to book a ticket on the airline, so in the airline reservation system, so more than one user can read the data whatever available in that particular system, right? But if any of the user tries to book the ticket at the same time, any other user who also trying to book the ticket is not possible. Okay, so at a time only one user can uh, uh, book the ticket. So this is what the good example for this reader writers problem. So let us see what is the code given here, how can we solve this particular problem. So here we have the first okay, so before entering into the code, so I'd like to tell about what is the concept of this readers writers problem, right? So and what could be the condition we need to check whenever any of the process performing this either read or write access. Okay, so now if the process wants to read, if more than one process wants to read the data, it is possible because they are trying to access only perform only the read operation, it is possible. Okay, but at the same time if more than one process wants to write the data, it is not possible. Whenever any one of the process is writing currently, the other process cannot perform the write operation or even the read operation itself. He cannot perform the read operation itself because while the writing operation is currently active by any other process. So this is what the condition to be satisfied in case of reader writer problem. So let us see the code first. We have the user defined variable called semaphore. Here also we have implemented the concept of semaphore in order to solve this problem. Semaphore mutex. So we have declared one mutex variable because whenever you are trying to access any common data, so we need to achieve the mutual exclusion. So mutual exclusion is nothing but at a time only one process can able to perform the operation whatever he tries to perform on the common data, right? Semaphore db equal to 1, so here the database and that value both these semaphore variable values we have initialized to 1, and we have one local variable called read count. So how it will tell you how many number of readers are there or actively doing their task. Okay, currently active, so how many number of readers are currently active at one time. So with the help of this variable value we can understand that. Then so here we have void reader, so we separately we have two process. So reader is said to be one process and writer is said to be another process. So whenever any user wants to perform this read operation, he has to achieve all these conditions whatever we have under reader. Okay, let us see. While true, down of mutex, so initially we are actually executing this down operation on the mutex variable. So if you want to execute any down operation on any variable, so what is the meaning of it? We are decrementing the value of that particular variable value. Probably it should not be 0 already, right? So we have initialized the value of mutex as 1, so it will if you are decrement, after decrementation it will become 0, no problem, which means the other no other process enters into the critical region at that time. So the process whoever wants to read can enter, okay, can access the database. That is what the concept of this, he enters into the critical region. Then or also we can say he can get the exclusive access to read count. So whenever any process wants to read that particular data, we have to increment the value of read count. So that is what we are doing. So initially the read count value is 0. So when any one process wants to read that common data, so read count value will be incremented. And also he has to check whether he is getting that exclusive access to read count. It is not actually, it does not mean that he is getting the exclusive access to database. So on this variable, so why we are checking the down operation on this mutex variable, in order to get the access to read count. Okay, so we have incremented it. And next one, up of mutex, we have released this read count variable, we have released. Now so which means any of the process performing this read operation, it will release it. Read database, which is nothing but it is the uh, accessing the data, and then down of mutex. Okay, so down of mutex, which is again any other process or the same process wants to read it again, so he can get the exclusive access to the read count. And the read count value will be decremented here. So read count value will be decremented. So because he wants to exit from the critical region, so he is just decrementing it. He performed his read operation, he completed its read operation, so he want to decrement it. Now this process is not currently in read state. So that is what the meaning of this. If read count equal to 0, then up of database, which is nothing but he is releasing the, if he is a 0 means he is the last reader, so he has to release that particular common data, whatever he is accessing, right? So releasing the exclusive access to database as well as that read count. Okay, and he enters into the non-critical region. So these are all the things that comes under non-critical region. Okay, and then I repeat this. So initially whenever the process wants to perform the read operation, he has to get two semaphore variables are there. One is mutex and another one is database, that is db. So he wants to get the access to read count. So initially we are performing down operation on mutex. So once he want to read, then read count value will be incremented, which means currently this particular process active in reading state, right? And then up of mutex, which is nothing but he released that read count because he going to read that database, the common data. And afterwards down of mutex, which is nothing but again he wants to get the access to read count because he need to decrement it. So because you want to exit from the critical region, so he needs to decrement it. So only by the value of the read count we can understand how many readers are active currently, because we are allowing more number of readers at the same time. So more number of process can perform the read operation at the same time. It is possible, it is possible in readers writers problem. At a time more than one process can perform the read operation, but in case of write operation it is not like that. So read count is the variable which is used to find out how many readers are currently active, how many processes are performing read operation. So that is what the meaning of the read count. So let us here in write a process. So here we have think up data. So think up data, which is nothing but some non-critical region. So initially the writer process will be non-critical region. Then when he wants to access that common data, so he has to he's supposed to perform this down operation on that particular variable, that is db. It is a semaphore variable, so he will perform it. And then write database, so updating the database, and then he will release that particular exclusive access. So whatever he accessed that common data, so you should release it, so he can allow any other process to perform either read or write operation. But at the time of writing by this particular process, no other process will enter into the critical region, which means they cannot perform either even the read operation. Not only the write operation, even the read operation also they cannot perform. Okay, so this is what in the solution we can allow the reader to perform it. But we are actually getting into one of the problem. So the problem is, I'll tell you the problem. So currently the reader is active. Okay, currently the reader is active, any one of the reader is active. And afterwards the writer is actually waiting. So writer is waiting. So if any other process wants to write the data, so what he can do, while the reader is active he cannot perform it. While the reader is active he cannot perform it. So he has to wait until the completion of this particular reader operation. And then after this writer also, some readers may arrive. Okay, some readers may arrive. Not only a single reader, more than number of readers may arrive. So the reader, while the reader, any of the reader is active, he can allow any other process to read, to perform the read operation. So whichever the reader is arriving at that time, so he can able to perform all these reader operation. Okay, but writer is not possible, writer is not allowable, so it is actually waiting till the completion of all the readers whatever that is arriving. So what does it mean? Writer process is actually waiting for indefinite time. It is actually waiting for indefinite time, so which we, it cannot perform the writing operation until the completion of all the readers whoever actually came after, even after this writer, whoever came even after this writer. So this will also leads to a starvation, right? So what we are doing, so we can allow the writer only after the completion of this reader. So whichever it is active currently, after the completion of the reader, writer must be allowed. So whatever the reader operation that may arrive after the writer will be suspended, because writer is waiting. So after that, if even if it is a reader operation, so it will be suspended, so it cannot be allowed to enter into the, I mean, to perform the read operation. So this is what some of the solution we can avoid the starvation situation whatever you are getting. So even when the waiter, I mean writer is waiting, so even if you get many readers, so that will not be allowed to perform its task. So only after the completion of that writer, the all other readers whoever enters, he can perform the task. So this is what we can avoid the starvation. But by this solution, so we are actually getting only the less concurrency and all, because of that it will lowers the performance level. So that could be one of the disadvantage of this readers writers problem. Okay, so this is what about readers and writers problem. So I just told about what are all the advantages and what are all the problems we actually got and how we rectified it. Even then, what is the disadvantage we faced? Okay, thank you.